Now let's go ahead and finish it up and do a couple examples of using the amortization formulas to actually solve some principles of a hypothetical loan. And another thing to keep in mind when working on them is that if you're trying to solve the monthly payment, we're trying to figure out R in the formula, which is what number one is all about. A is always the principal, the amount borrowed to begin with, and P and N are exactly the same variables from all of the other videos. So again, I'm trying to be consistent with everything I do, and you'll notice some similarities. I mean, it is the same thing as what the book does, just they use a few different variables, but it should all be consistent. If you prefer the book, I'm not going to be, uh, I'm not going to take that personally, but have my own system. Cool. So let's jump into an example. Example 11, suppose you have a student loan balance of 50,000 at a nominal interest rate of 7.2% compounded monthly, and let's say we are going to plan to take 20 years to pay it back. Let's first figure out how much are we going to be paying on a month by month basis. So basically we could start by finding the monthly payment, which is going to be given by R is equal to A divided by A and P. And the more you start practicing with these formulas, the easier it is to get the hang of the structure, which is a little bit unusual at first, but it starts to, in my opinion, make a little bit more sense after a little while. So since A is the amount I borrowed, the principal of my loan, 50,000, and little a and p is going to be determined by the number of payments and the periodic interest rate. So again, the periodic interest rate will be 0.072 divided by 12, which I think I know what this is, but let's go ahead and do it with a calculator just to be safe, is zero point 0.6. And with two decimal places further, because I did not move my decimal place when I typed in my calculator, that would actually be 0.006. So 7.2% divided by 12 is 0.6%, which is the periodic interest rate. Each month it will be growing by 0.6%. And then the number of payments, capital N, is always going to be, well, it's 20 years and it's 12 months in the year, which is 240 total payments. So basically, I'm going to be evaluating A at 240 and at a rate of 0.006. And doing that all in the calculator, again, I have the longer version of the formula right here. I could take A times P divided by, I know A is 50K, 50,000 times 0.006 divided by 1 minus 1 plus p to the n. 1 minus 1.006 to the minus 240 power. And that calculation should give me the correct monthly payment in order to properly pay off the loan on time. So 50,000 times 0.006 divided by 1 minus 1.006 to the negative 240 power, which amounts to be $393.67. In this case, I should probably round up because if I round down, I'm probably going to come out a few cents short, but I don't really care at the end of the day. So we'll just round conventionally, but probably should round up. Anyways, cool. So if I pay off that 393.67 every month for 20 years, my loan should be paid off perfectly, exactly right on. Well, aside from the slight rounding error. And that will compensate for all of the interest that is accrued over that period of time. So fairly simple at the end of the day, but this amortization formula, as is right here, was all we derived that from the idea of an annuity and the present value of an annuity. So our present value is how much we're currently buying it for, and we're spacing it out into a bunch of payments, which is the relevance of present value in annuities in all of this. But kind of more interestingly is we could also look at some of the other formulas like, well, how much total interest was paid? And there is a formula for interest paid up there, but I don't think we need it because we know exactly how much our monthly payments are for this loan. And we know that there's a total of 240 installments. So if I think about what paying it off will mean, I'm going to be paying exactly that much, that payment for 20 years, which amounts to 240 total payments. So I can figure out what is the total amount that I've paid by just multiplying those two things together. So $94,480 and 80 cents is going to be the total amount paid over the lifetime of that loan in all those payments. So if I was just sort of to add up the raw value of the annuity payments, that'd be that. And if you look at, well, what's the total interest paid? It's just n times r, which is exactly that, n times r minus a, the initial price of the annuity, or basically the principal value of the loan. So basically, this is pretty simple now, because I found the total amount I paid, but I also know how much did I borrow. I borrowed 50,000. I paid 94,000. So if I take just the difference of those two things, which is exactly what that formula says to do, take n times r and subtract away a, that would give me my interest. So subtracting that all together is $44,480 and 80 cents. But what that leads me to believe is I have paid $44,000 in interest over those 20 years on my student loan. So I borrowed 50K, I paid off almost double that, and I can calculate the net interest paid in that period of time. Which, if you've never really looked at the math of how home loans or student loans work, is quite alarming to people the first time they see it. And it's definitely something that I think is important to be educated about before you take out a loan. But reminder about loans is that you don't have to make, this would be like our minimum payment over the loan. We can pay off more than the minimum, which will lower the balance and pay off more interest up front. And the faster and faster we pay off that interest, the less time it has to accrue. So general financial rule of thumb is pay off your loans early if you can afford it. And don't just make minimum payments in general, because interest is the enemy of those who want to have their money working for them. If we're paying interest, it's like negative money that is not. My mic cut out. I guess that means it's time to shut up and move on. But basically, this is why we want to be investing our money. Instead of borrowing money, it's better, obviously, to be investing it. If we have money, we want to be putting that to good use, investing that in various funds that could be generating interest for us. So, having our money working for us rather than working for our money. And this is not to say that student loans are bad, because you're investing in yourself and in your education if you have had to take out student loans, which is obviously worth it, depending on, obviously depending on what you want to do. But I digress. And before I close up this section of the video, I wanted to mention that our second project will be on building an amortization schedule in Excel. So next week I'll work on a video, like a tutorial about how to get started with the project, kind of what to do, but it'll be an offshoot on exactly this lecture here. So if you want to kind of bookmark this in your brain to come back to it. Also with calculations 2, 3, and 4, it can help in the calculator as well, but I'll teach you how to build it all from the ground up, which is very handy in the world of finance. So anyways, have a nice day. See you all next time.